You'll often see quadratic functions in either standard form or vertex form. In this example, I want to explore a quadratic function that is written in vertex form. When a quadratic function is in vertex form, there's a lot of information that you can get from the form itself using what we know about transformations, or sometimes they're called translations. So the first thing you do when you're working with transformations is to identify the parent graph, and we can identify our parent graph from this squared, so we know that the parent graph is our basic quadratic formula, basic quadratic equation. The A indicates whether or not we're going to flip our basic quadratic graph, which we know is a parabola. Are we going to flip that over the x-axis, and whatever number that A is will tell us that. In addition, that A also tells us whether or not our parabola is going to be compressed or stretched. Another thing that we can tell when our function is in vertex form is whether or not we are shifted, whether or not the center point is shifted from 0, 0. So this H gives us that information. So that gives us our left-right shift. And finally, K gives us our vertical shift. So K tells us whether or not we're going to move up or down from that 0 point. So let's look at a specific example. We have f of x is equal to the quantity x minus 2 squared plus 3. We know this is going to graph out as a parabola. We're just not sure exactly where that parabola is going to be on our graph, and whether it's going to be wider or whether it's going to be upside down, etc. So first, let's look for A. Now, in this function, it looks like there is no A, but that is an implied 1. And that means that we're not going to flip, we're not going to compress, we're not going to stretch. The next thing we'll look for is our left-right shift, and that 2 gives us our left-right shift. So we know that we're going to shift right by 2 units. So instead of being at the 0, 0 point, so our center of our graph is no longer at 0, 0, we're now shifting over by 2. And then our K for this example is the 3, and that tells us we're going to go up 3. So our new center point over 2 and up 3 is going to be in this vicinity. There we go. So this is our new center point. And so our graph is going to be a parabola, and we know that it's not flipped, so we know it's going to be a right side up parabola. So it's going to look something like this. Now you can get much more precise, and you can find other points to determine exactly how wide that parabola is. And sometimes you do need that level of accuracy. But for our purposes right here, we're just doing a quick sketch. I want to take a look at some of the other information that you might need to give about your function. We're often interested in what the domain is, and remember, the domain is the set of all legal inputs, so all the x values that can be plugged into this function that don't cause it to blow up. And in the case of this quadratic, we can plug in any number that we want. There isn't any number at all that's going to cause this thing to blow up. So each and every real number is legal. So we go from negative infinity to positive infinity. Next, we look at the range, which is what are all the possible y values? What are all the possible output values from this function? And we can look at the graph to give us a hint. We notice that there's no y values that go below 3. So that vertex actually represents the lowest value that y takes on. So we don't go any lower than 3. 3 is included, and then from there we go up forever. So our range is 3 to infinity. We often want to know what the vertex of a parabola is, and the vertex is simply its center point. So this point that I'm pointing at right there, that is the vertex, and so we already know the coordinates of that. That would be at the point 2, 3. So the vertex represents a single point. One more piece of information that we often would like to gather is called the axis of symmetry. And if you can imagine, just visualize the axis of symmetry is a vertical line that goes through your center point. So let me put in a dotted line here. So this would be the axis of symmetry. So if you had this on a piece of graph paper and you folded the graph paper along that line, that dotted line, you would see that the two halves of that parabola sat one right on top of the other. So our axis of symmetry is a vertical line, and it's the vertical line at x is equal to 2. So that's the information, and you can easily get that either from the equation itself or from the graph. Now notice one thing about the vertex. I'm sure you've noticed this. We said the coordinates of the vertex were 2, 3. And notice the values of h and k. So we can actually pick the vertex straight out of that function. And that's it.